In this section, we'll talk about preparation of amides and its reactions. So whenever we are looking at amides, as I said earlier, the amides are made up of a carbonyl connected to a single bond and a nitrogen. So this is going to be the amide bond. When you want to prepare an amide, you have to break this bond in there to know what are the reactants that the amide came from, okay? Now, normally, amides, they come from derivatives of carboxylic acids. They are made from derivatives of carboxylic acids. So what we do over here is that we break the amide bond, and the part that is connected to the carbonyl in the amide, this comes from the carboxylic acid derivative, and the part that has a nitrogen, this comes from ammonia or primary amine or secondary amine. So it comes from ammonia reagent, because after all, I need to use a reagent that let's write it right, that has a nitrogen in there. So that is going to be ammonia, or it can come from a primary or a secondary amine. Okay, so to prepare amides, I need to use a carboxylic acid derivative. There are two carboxylic acid derivatives that I can start with to make this amide structure in there. I can start either from acid chlorides or I can start from anhydrides. So that this takes care of this part over here. And then the second part, I need to react the carboxylic acid derivatives, any one of those that I choose, with either ammonia, primary or secondary amine, in order to get the desired amide that I want. So let's go ahead and have an example in there. Okay, so the derivative of the carboxylic acid is a must, and we're going to limit to either using acid chlorides or acid anhydrides. In these types of reactions, when acid chlorides react to form the amide, it loses a chlorine, okay? And when the acid anhydride reacts to form the amide, it loses this part over here, which is the O carbonyl and the R. Both of these are good leaving groups, but of course, the chlorine is a better leaving group, so this one is a better leaving group, and that makes the acid chlorides very reactive. What does that mean? It means that we always recommend, whenever we want to make an amide, to start with acid chloride versus anhydride. The reaction is smoother, works faster, but still the reaction works with acid anhydrides. So the rule over here says that whenever you're doing a reaction with a derivative of carboxylic acid in there, you have to know what type of ammonia derivative you are working with. So here I'm working with ammonia. So that is going to be ammonia in there. Okay, the reaction is going to proceed by the ammonia loses a hydrogen and the acid chloride loses a chlorine. So your byproduct is going to be HCl in this case. And then I'm going to combine all of those together to make the amide bond. Always make sure to write down the general structure in there of the amide. So that is going to be an N. So you are making that amide bond in there. Okay, this is always what you're doing. So you are going to draw a bond between this carbon and the nitrogen to make the amide bond. I'm going to use the same number of carbons that I have here. So you're going to break this bond. Okay, we're going to form HCl as a byproduct. So I have this part of the acid chloride that is left in there. So I'm going to go ahead and write it down. Here you go. Make sure that you copy the same number of carbons in here. And then I'm going to make a new bond. This is going to be my amide bond. And then the rest of the ammonia that is left, which is the NH2 over here. So I'm just going to go ahead and simply add the NH2 in there. okay, plus of course my HCl, and that is going to be my byproduct. What did I form over here? I did form a primary amide. So now I know that if I start with ammonia and an acid chloride, so that is an acid chloride. Acid chlorides are very reactive. Then in this case, I'm going to make a primary amide. Now, to make a primary amide, the type of the acid, the carboxylic acid derivative honestly doesn't matter. The type of the reagent, the nitrogen reagent that you're using matters here. So because you notice that the primary amide has two hydrogens there on the nitrogen. So definitely your nitrogen reagent needs to have 3 hydrogens so that one is taken and the others remain. So I have to start with ammonia to get a primary amide. Okay. Let's have another example with the acid anhydride. So we said that with the acid anhydride, what I am breaking in this case is this bond over here. And this whole thing is going to be my leaving group. It's going to leave. And I'm going to use a hydrogen from here. So those two are going to leave. And whatever is left from the acid chloride part, from the ammonia part, I'm just going to group together and I'm going to get my amide. So this is still my ammonia. And this is an example here that that I wrote just to tell you that I don't care about the type of the acid chloride. As long as I'm using ammonia, then my product is going to be a primary amide. So this is what I have left from this part of the acid chloride. I have 1, 2, 3 carbons left. I'm just going to combine them with the NH2 over here. So I am making my new amide bond. And then we have the NH2 on the other side. Plus my byproduct. What is my byproduct? My byproduct is this whole thing that is left from the acid anhydride. So go ahead and write it down. So I have the O, the carbon double bond O, and then the CH2, and then the CH3. And that is going to come and bond with the hydrogen, and this hydrogen is simply from the ammonia in there. Notice how did I put the hydrogen? I made a bond between the oxygen and the hydrogen because I know that oxygen should have 2 bonds in 2 lone pairs in order to be a 0 charge. So the hydrogen has to be on the oxygen there. This is a byproduct as well. It is an acid byproduct. So that is going to be a carboxylic acid byproduct. And my product here is still a primary amide. So to make a primary amide, I have to start with ammonia and any carboxylic acid derivative. Let's have another example. Here I'm starting with a primary amine. Notice the difference. I'm starting now with a primary amine. So the rule says that if you're starting with a primary amine, every time you're going to be losing a hydrogen. So your product is going to be a secondary amide in this case. Whether you're starting with an acid chloride or you are starting with an anhydride, it doesn't matter. Just you have to know what are you losing. Acid chlorides, you are losing a chlorine in this case. You're gonna lose a hydrogen from here. Always amines lose a hydrogen, always. And then you're going to combine your amide together. So that is going to be your amide. It's going to be the first part of the molecule. Make your amide bond. And then you have the NH and then the CH3. Okay. Plus, of course, whatever is left, which is the HCl byproduct. My product now is going to be a secondary amide. So if you want a secondary amide, guys, you have to use a primary amine reagent. If you want a primary amide, you have to use ammonia as a reagent. This is another example in there with a secondary amine now. Okay, again, all amines have to lose hydrogens. This means that this reaction cannot happen with tertiary amine because tertiary amine have no hydrogen to lose. So I only can use ammonia, primary or secondary amine, because all of those, they do have hydrogens in there. So the secondary amine will lose a hydrogen, the acid chloride is going to lose a chlorine, and simply you are going to combine whatever is left. So I do have a carbonyl. This is the part that is left from the acid chloride. Make your amide bond, and then you have the part that is left from the secondary amine in there. Plus, of course, you do have your HCl as a product, and now your product here is a tertiary amide. Okay, so I do have my tertiary amide formed whenever I react a secondary amine with the acid chloride. I have my secondary amide formed whenever I react a primary amine with the acid chloride, and I have a primary amide formed whenever I'm starting with ammonia and acid chloride or anhydride. So it doesn't matter the derivative of the carboxylic acid. As we said, what matters is the type of amine that you are working with. So let's have another example here. If I am using an anhydride, this one is an acid anhydride. You just need to understand and know where to break the bond. And to break the bond is the bond of the functional group. So basically what I'm doing is I'm losing this whole thing. This whole thing goes away, and the hydrogen goes away, and then I'm going to group the amide together. So I am going to end up having a carbonyl, form the amide bond, and then on this nitrogen, make it connected to the nitrogen because this is the amide bond, and then you have your two R groups in there, plus of course the not HCl, I'm sorry, it's not an HCl over here, because you're starting with an acid anhydride. So it is a hydrogen, but that hydrogen is connected to an oxygen and then a carbonyl. It's actually everything in there. So you have your, just to draw it as you see it, you have your carbon chain, 3 carbon chain in there, and then you have a methyl on that carbon, and your byproduct here is a carboxylic acid. Okay, every time you work with acid anhydrides, your byproduct is a carboxylic acid. Check the answer. Secondary amines always gives me a tertiary amide, always. Okay, so what you can do is simply just add 1 degree every time you are using a reagent. So a secondary gives me a tertiary, a primary gives me a secondary in there, and regular ammonia just gives me a primary amide with the derivatives of carboxylic acids. So this is one reaction of, this is one way in order to prepare amides. Another way to prepare amides is simply to react an amine with an acid. And this is a simple acid-base reaction in this case. So the amine is going to behave as a base, and it's going to behave as a base from the nitrogen. We know that bases take acidic hydrogens. This is what we talked about. So here the amine is going to be a base, and the carboxylic acid is going to behave as an acid from this hydrogen over here. So that is going to be the carboxylic acid. To name this is propanoic acid. Okay, and this acid over here, it's not very reactive. So if I want to compare a carboxylic acid versus derivatives of carboxylic acids, the derivatives of carboxylic acids are way better in order to make amides in there. So carboxylic acids, these are not very reactive to make amides directly. Amides directly, like the derivatives of carboxylic acids, like the derivatives of carboxylic acids. So this is why if you want to make an amide this way, then you would need to pass by 2 steps. Make the product, then heat it up, and then you will get the amide. Okay, So amides are made better by the derivatives of carboxylic acids. If you want to go ahead and use carboxylic acid instead, you will use an acid-base reaction where you are going to follow the same rule as we already talked about. Bases, come take those acidic hydrogens in there, and you will get a conjugate base and a conjugate acid. So let's write it down. So that is going to be the leftover of the acids turn into bases. So here you go, that is the leftover in there. And then the nitrogen, since it took hydrogens, it needs now to have 3 hydrogens next to it. So it already has 2 hydrogens, already had 2 hydrogens, and I added one more, okay? And then of course I have a CH2, CH3 there. So now I ended up having a plus charge on this nitrogen in here, and I'm forming an ammonium salt. So that is considered to be an ethyl ammonium. It's an ethyl ammonium, and this one over here is 1, 2, 3. So it's going to be an alkylate because it's a derivative of carboxylic acid. So it's going to be a propanoate. Okay, here you go. And that is a salt. Okay, because it does have plus and negative charges in there. Notice here I did not form my amide yet, because this one is not very reactive. So I can stop here if I don't use heat. But if I use heat, then I can simply take away water. What are the water molecules that I can take here? I can take here what are the elements to take water? It's 2 hydrogens and an oxygen. So if I apply heat, I can simply take away my water molecule in there. If I apply heat. If I don't apply heat, then I'm going to stop at the ethyl ammonium propanoate. I'm not going to continue further. So applying heat, we're going to take all of those out in there. And then when we do, we're just going to combine the leftovers. So combining the leftovers in there, that's going to make the carbonyl make a bond to the nitrogen. I have an NH and the CH2 and the CH3 in there. And that is going to be a secondary amide. So when I start with a carboxylic acid and use a base, I'm going to get my salt. If I go ahead and apply heat, I'm going to get my secondary amide. But notice, I got my secondary amide because the base that I have over here is a primary amine. And that primary amine, after the reaction, I ended up having enough hydrogen atoms so that I can lose the water molecule in there. So let's say, for example, if I give you a tertiary amine, okay? Now that tertiary amine doesn't have hydrogen molecules, or hydrogen atoms, I mean, on that nitrogen in there, but it is a base. It behaves as a base. Why it is a base? It is a base because the nitrogen has lone pair. So this is going to be the basic part. So I can apply the rule that bases will take the acidic hydrogen. Okay, so when this happens in here, then I'm going to end up getting my carbonyl. This is an O negative. And then, of course, my positive counter ion. I do have an N. I do have a hydrogen there. And I do have a CH3. I have a CH3. And I have a CH3. That is a plus charge. So what I formed here is a trimethyl ammonium, and that is going to be a propanoate. Okay, I'm going to stop here because I cannot continue further. I cannot use heat because if I use heat, I do not have enough hydrogens on the nitrogen to lose water. So the reaction is going to stop here. There is no heat. Okay, heat is represented by a small triangle in there. So there is no heat since we cannot lose water. Okay, so since we cannot lose water molecule, so the reaction is going to stop here. So see the difference between a primary amine and a tertiary amine. With primary amine, I could continue and simply lose two hydrogens. I can also do the same thing with a secondary amine. So if I have a secondary amine in there, I can also lose water molecules. But if I have a tertiary amine, the reaction is going to stop here. There is no loss of water, so I cannot make my amide from tertiary amine. I will only have an acid and a base reaction to make my ammonium salt.